the second half of 3.2, what we're going to be looking at is synthetic division. Now, long division has its time and its place, and it has to be used on certain functions, but there's also some special functions that you can use this synthetic division for, and it will make it go really quickly. So hopefully you've practiced on the long division before you viewed this video. So with synthetic division, you can only use division when you have an x minus k as what you are dividing by. And each time we do this, we're going to take this and say it equal to 0 in order to add that k over and find our k value. It's important for us to find our k value because when we go do synthetic division, we're going to set up kind of a backwards L over here. We're going to take our k and put it out front, and then we're going to put all the coefficients of the polynomials in here. And so if you've ever made the request of, when did math add all the letters, today is your day, because we're going to take all the letters out of it, and we're just going to work with numbers. And so the best way to kind of show you this is to do some examples over and over and over. And in this lesson today, we're not only going to learn how to do synthetic, but we're going to look on how it can apply to other means. And this lecture is also going to help you at the beginning stages of 3.3 as well. So you are going to see some overlap as you're using your notes. You're going to need these notes for a little bit of the next section as well. So let's just kind of dive in here. So the best way to kind of show you how synthetic division works is this is going to be our setup, but I think if we work with a real problem, it'll make more sense. So the first thing you notice is we're dividing this long polynomial by x plus 3. So the first thing you want to do is you want to take this x plus 3, bring it out here to the side, set it equal to 0 in order to find your k, the number that we're going to put out front. Sorry about that. And so what I'm going to do is I'm going to subtract 3 from both sides. So this gives me x equal to negative 3. So this right here is going to be my k. So I'm going to place negative 3 out front. I'm going to draw a large backwards L. You'll notice with the long division, you're doing it, and it takes like a half-page notebook paper. You're going to like this because this takes 3 lines on your notebook paper. Then, after you find your k and place it out front, it's crucial that you're able to find that k because not getting the correct sign on that 3 can be the change of the whole problem. Then you're going to list your coefficients in descending order by exponent. So you can see this is a 4th degree. If there's not a number in front of it, that's a 1, so I'm going to place a 1. Then I look for my x cubed, and I don't have 1, so just like with long division, you're going to place a 0 there as a placeholder. Then you take your coefficient of your x squared, which is negative 10. Again, look, notice I'm only writing numbers. I'm not writing any letters. Then your x, which is negative 2, and then your constant, which is 4. So you place your k out front, and then you take your coefficients in descending order of exponents, and only the big numbers in front of the letters. Then, this is what you're going to do. And if you're watching the video, I would suggest you just kind of watch instead of taking notes, and then pause it and go and fill in your notes in just a minute because it's going to go really fast. So just watch as we go for this first one, and then you can work along with us in the other ones. So the first thing you're going to do is you're going to bring down this 1, and I would put an arrow here every single time so that you don't accidentally put a number there. Then with long division, you did multiplication and subtraction. With synthetic, you're going to do multiplication and addition. So I'm going to multiply these two numbers here. Negative 3 and positive 1 multiplies to give me negative 3. I'm going to place it in this next blank. Then I'm going to add. 0 and negative 3 adds to give me negative 3. I'm going to place that number here. And I'm going to multiply. Negative 3 times negative 3 is positive 9. I'm going to place that here. I'm going to add vertically. Negative 10 plus 9 is negative 1. Then I'm going to multiply. Negative 3 times negative 1 is positive 3. And then I'm going to add. Negative 2 plus 3 is positive 1. Then I'm going to multiply. Negative 3 times 1 is negative 3. Then I'm going to add 4 and negative 3 to give me positive 1. So you can see synthetic went really quick. If you know you're not very good with multiplying and adding negative numbers, grab your little calculator, use the negative button on it, use that to help you get through all this, because one small mistake can domino out of control, just like you saw with long division. Look how beautiful that is. There is no letters written in synthetic division. I thought you would really like that. But what is interesting is this long division helps us to see what the result will be, and here's how you, so this is all my work. Now it said to divide this polynomial by x plus 3. So what would my answer be? Well, if this is x to the fourth, we're dividing by a first degree polynomial, so that means it's going to reduce down to an x cubed. So my answer would be x cubed, or 1x cubed, minus 3x squared minus 1x plus 1, and then this number right here is your remainder. And just like in long division when we got that very last piece, is your remainder, so you say plus 1 over what you were dividing by, so over x plus 3. So this would be my final answer. Isn't that beautiful? I mean, if you have to say anything's beautiful in math, look how beautiful that is. I mean, you can see it goes really quickly. Just make sure you're multiplying and adding correctly and you have all your numbers in the right spot. So let's execute that again. Let's do this one. And if you feel okay with it, pause it and see if you can do it on your own. But if you'll notice here, so I've got my polynomial divided by x plus 3. First thing I'm doing is I'm going to find my k. So I'm going to set x plus 3 equal to 0. I'm going to subtract that 3 over, and I get x equal to negative 3. So this would be my k. So I'm going to put negative 3 out front and draw my large backwards L. Then I'm going to plug my coefficients here. My coefficients would be 2, 10, and 12. X squared, x constant. Again, descending order of exponents, only the big numbers. If you're missing any, put in a 0. Bring down your first number, which is 2. Multiply, and then add. Multiply, and then add, and then 0 would be your remainder. So, this being said, this started out as an x squared, and now we're at an x. So our answer would be 2x plus 4. We had a remainder of 0, so we don't have to put 0 over that x plus 3, and this would be my answer. And you can see how really quick this went. Let's do one more, and then I'm going to show you how synthetic can be used, not only just for simple division. I say simple, you may not feel simple. Not only can it be used for just straight division, that's a better word, but it can be used to help us to do other things that are mathematical concepts. And so again, let's do this one. So first thing I'm do, as long as you're dividing by x plus or minus a number, you can use synthetic. You'll notice in the homeworks, they have numbers attached to your x, or they have x squareds that you're dividing by, and you cannot use synthetic for those. So you've got to know both processes. And you'll have problems on your exam for this unit, and it'll say use long division, and you must use long division. There will be ones that have synthetic, and you must use synthetic. And those problems will probably be ones that you can't do the other version of it. So now let's find our case. This is x plus 2 equal to 0. So I'm going to move that 2 over by subtracting it. So I get x to be negative 2, and so this is going to be my k value. Once you have your k, you're going to place it out front. Draw your large synthetic notation here, and then I'm going to place in my coefficients. It's an x cubed, so I'm going to take the coefficients. This would be 3, 8, 5, and negative 7. You're going to bring down the first number. I always put an arrow there, one, so I can see what I'm doing, two, so I don't accidentally place a number there and then mess up the problem, because again, this can domino out of control if you make a small error. Then I'm going to multiply. Negative 2 times 3 is negative 6. And then I'm going to add. 8 and negative 6 is 2. Then I'm going to multiply. Negative 2 times 2 is negative 4. And then I'm going to add 5 and negative 4, which is 1. I'm going to multiply. Negative 2 times 1 is negative 2. Then I'm going to add negative 7 and negative 2 to give me negative 9. So this last number here, again, this is my remainder. And so what this results in, when I divide this polynomial by x plus 2, so it starts out as an x cubed, it ends as an x squared, and I'm just write my letters in descending order, x and then my constant. So my answer would be 3x squared plus 2x plus 1 minus 9 over what I was dividing by, x plus 2. Now be careful in the online homework, the way they're setting it up, some of them are already giving you this over x plus 2 and they just want you to plate this in the box above it. But if you have any struggles with the homework as we go, just feel free to shoot me a Canvas message and I'll be happy to help you out along the way. Okay, so this is dividing with synthetic. The use of synthetic is not only helpful in just division of problems, but it also helps us to do some other processes. Another processes that it's used for is synthetic for evaluation. So you can actually use synthetic to evaluate a polynomial. So I'm going to go ahead and set up my synthetic division. This says x equal to a number, so there's my k already. say -2. And then these are my coefficients, 3, 8, 5, and -7. I'm going to do my synthetic pretty quickly here. So I bring down the 3, multiply, add, multiply, add, multiply, add. And what it does is if I'm using synthetic to evaluate a function, what I get as my remainder is my answer. And what this shows me is if I were to go in here and evaluate the function at -2, I would have to do -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. I have to plug and check through that, and it would also give me -9. So this is known as the remainder theorem using synthetic. And basically, using small steps, I'm able to get to the evaluation at -2, just like I would plugging and chugging. And you will have on your exam a question. It will say evaluate using synthetic. If you go back to day 1 and you go back and you plug and chug through it and you don't show that you can use that remainder theorem, do your synthetic and get your answer, then you will not get full credit on that problem. So make sure you follow the instructions for each of your exam questions and follow your instructions in your homework because that's the good practice for it. And you'll have many of these on 3.2 and 3.3 of evaluate, and so it also gives you good practice skills for your synthetic. So notice I didn't write 3x squared plus 2x plus 1. All I want is -9, so it says synthetic can be used to evaluate. F of x, evaluate x equals 2. I'd say that's -9. Box it up. And that would be my answer for this problem. So make sure you follow all instructions because 1, it gives you practice within the homework. That's the point. That's why it's called practice. And 2, on the exam, I want you to receive full credit. So I'm warning you now. Make sure that you're using the concepts that we're learning. You don't go back to day 1 and just plug and chug through. Another good use of synthetic is we can actually factor and break down these large polynomials where we couldn't factor them before. We know how to factor quadratic functions and we know how to do quadratic formulas. That's only for a power of 2. I have a polynomial of power 4. When I'm looking at the power of 4 and I want to break all that down, this is where synthetic's going to come into play. So it says show that x minus 2 and x plus 3 are factors of f of x. Then find the remaining factors. So my end game is I'm going to break this down into all the linear factors. Synthetic is going to use that for me. So first thing I need is I need to show that x minus 2 is a factor. The way I'm going to show that is I'm going to take x minus 2, set it equal to 0. I'm going to get my k. And I'm going to do synthetic using 2 as my k. So I have 2, 7, -4, -27, -18. I'm going to do synthetic, multiply, add, multiply, add, multiply, add. Again, just use your calculator as you go to help you out. And you'll notice I get 0 as a remainder. So what this 0 as the remainder does is this shows that, let's write that, shows it's the factor of x minus 2. So it shows me that x minus 2 is a factor of that. It will divide it nicely because I'm getting that 0 remainder. Now next thing I do is I need to show x plus 3 is a factor. Now my end game is finding all the remaining factors. So what I'm going to do, I'm going to grab my k value over here. I'm going to continue my synthetic with what I have left over so I can further break down this problem. You'll notice this is an x to the 4th, so now I'm down to an x cubed. If I can get that down to an x squared, I can handle it from there. So you could go back up to the original, but it would not help you like it would just using your result. So I'm going to break this down. I'm going to multiply, add, multiply, add, multiply, add. So again, this shows it's the factor of x plus 3. And now I have to find the remaining factors. Well, that means x minus 2 is a factor, x plus 3 is a factor. Let's see, I have an x squared left over. So I have 2x squared plus 5x plus 3. And then you can see here that that's a quadratic, so I can factor that. If you need more assistance with factoring quadratics, we did it back in Unit 1, but I'll be happy to send you any resources to help you out with that. So just shoot me a Canvas message and say, hey, I need some more help with factoring, you know, what you got? So message me there. Let's see, the signs are both going to be positive, and want to multiply to give me 3, be 3 and 1. So you can see, notice this, I was able to factor pretty quickly at the beginning a fourth degree polynomial into all of its linear factors. And so it says find the remaining factors, so those would be my remaining factors. So in order to receive credit for a problem like this on an exam, you have to show that 2 is a factor, show that x plus 3 is a factor, and find the remaining factors. So 1, 2, 3, 4, 5 points going on here. So make sure you're working through the problems efficiently and correctly, following all steps, because you want to receive full credit and be able to handle any problem that's given at you on the exam. Let's do another one. So it says x cubed minus 7x plus 6 is equal to 0 has a 0 at x equals 2. Find the other zeros. Remember, when you're looking at zeros, these are also called solutions. These are also your x-intercepts. So we're still finding zeros or x-intercepts of a function. So they're giving you a starting point here, and it's already equal to x, so it's going to be your k. Get the camera to catch up here. So then 2 is going to go out front. And I'm going to write my coefficients. So 1 is the number that's in front of your x cubed. 0 is your x squared because I don't have one. -7 is your x. And 6 is your coefficient. So we're going to do synthetic given our starting point. So I'm going to bring it down. 2 times 1 is 2. Add, multiply, add, multiply, add. And I better get a 0 for remainder because they told me that was a 0. So getting a 0 here shows x equals 2 is a 0. Now to find the other zeros, let's see what I got here. This was an x cubed and now it's an x squared. So if I were to write this in linear factors, it would be x squared plus 2x minus 3. And I can handle that. We could factor that a little bit further. That would be x and x. The signs would be different. You think what will multiply to give you -3 and add to give you +2, and that would be 3 and 1. So notice here, this is a fully factored third degree polynomial. It asked me to find all the zeros of the function, so I just set each of those pieces equal to 0. So I have x plus 2 equal to 0, so x is -2. X plus 3 equal to 0, so x is -3. And x minus 1 equal to 0, so x is 1. So find all the zeros. I could say I have zeros at -2, -3, and 1. Just be careful with the wording. This one said find the other zeros, so they're probably not going to include -2 in typing it in the box. So you can see synthetic really simplifies some of our processes and breakdowns. And you can see we're doing less work on a page than when we're doing with that long division. Last problem. I'm just giving them to you in different forms that you might see. It gives us a function and it says these are factors. So it told us to find the remaining factors. So we're going to find the remaining factors. It says to write it fully factored. So it wants that polynomial broken down to everything that was multiplied to get it. And then 3, find the zeros. So I'm going to have to fill in a few blanks as I'm working through this. So first of all, use your factors to get you going. So I'm going to use this one first. This means I'm going to have a k of -3. Say -3, 3, 2, -19, and 6. I'm going to do my synthetic. So 3, that gives me -9, -7, 21, add, multiply, and by golly, you better get a 0 because they said it works. Then from what you have, do synthetic again with the next factor. So that would mean I have a k of 2. So I'm going to bring down the 3. I'm going to multiply. I'm going to add, multiply, add. And again, by golly, you better get a 0 there because you can see that they told me those worked. Then look at what I have left. This was an x cubed. Now it's an x squared. This is just an x. So I would have x plus 3, x minus 2, and then my last one here, 3x minus 1. So find the remaining factor. We did. There it is. Write it fully factored. That would be all of this. And then find the zeros. So just draw my table and set each piece equal to 0. So x plus 3 is 0 to give me -3. X minus 2 is 0 to give me 2. 3x minus 1 is 0 to give me 1/3. So you can see the synthetic really simplifies our life and helps us to work with other things. So I hope this helps for 3.2, just the remaining part of those questions. But remember, this is also going to help you moving into 3.3, so you can go ahead and start on that homework as well. And then there's a video for the rest of 3.3. Contact me through Canvas messaging if you have any questions along the way, and best of luck.